Okay, Assalamualaikum and good evening to all. Today I would like to present the Chemical Engineering Laboratory Report Experiment 9, Effect of Process Parameter on the Rate of Evaporation. Okay, first of all, I would like to introduce our group members, Sio Yanjin, Nurjihan Najwa binti Az-Zahari, me, Tasnib Ashikin binti Tarmizi, Nur Ain Zuhaira binti Zulkifli, and Nur Kuzaidayu binti Ismail. Okay, next. Introduction. For the introduction part, in order to produce a concentrated solution, a solution consisting of a volatile solvent and a non-volatile solute is being concentrated by evaporation. The evaporated volatile component is the main product in some special cases. In processing foods, chemicals, and pharmaceuticals, the unit operation that is extensively used is evaporation. The vapor in evaporation process is usually a single component and there is no attempt to separate the vapor into fractions, which is different from distillation. Okay, in this experiment, the evaporator unit is a single tube pilot plant vertical evaporator, long vertical tube with a heating jacket, cyclone separator, distillate cooler, concentrate receiver, and distillate receiver are parts of the evaporator. The lower part of the jacket is where steam from a laboratory steam boiler is being fed and it exits through a steam vent. Before the steam condensate goes to the drain, it passes through a steam trap first.
Okay, good day, doctor. My name is Yanjin, and now I'll proceed with the result part. So this is basically the raw data at different steam temperature, steam pressure. We fix the flow rate and set the steam pressure at 0.2, 0.44, 0.63, and T1, T2, T3. T1 is the steam temperature, T2 is the separator, T3 is the temperature we cool down, and concentrate volume, distillate volume, condensate volume is the volume that we collect at the end of the experiment. And of course we also measure the height when boiling occur. So this is the calculated parameter at different steam pressure. The calculation I will mention later. So basically we calculate capacity, percentage of feed evaporate, rate of concentrate, rate of distillate, rate of condensate, sensible heat load, evaporative heat load, heat input to the evaporator, and lastly is economy. So this is the graph that we obtain at different steam pressure for the rate of evaporation, and when the steam pressure increase, the rate of evaporation increase too, as we can see from the trend in the graph, which same we also compare economy with steam pressure. When the steam pressure increase, the economy also increase. So this is the raw data for the feed flow rate. We fix, so at this one we fix our pressure, steam pressure, and we manipulate the feed flow rate to see what is the effect of the feed flow rate on the evaporator, on the evaporation process. And as you can see, we also obtain the same result as the previous one. So this one also the same. And now this is the graph it looks like. So when the rate of evaporation, when the feed flow rate increase, the rate of evaporation increase. But as you can see from the last one, it decreased. This is maybe caused by the time we set. For the last reading, we set it as 10. But for the previous one, we set it as 5. So maybe it affects the result. And for the economy part, also the same. When the feed flow rate increase, the economy increase. Okay, so this is the calculation for each section that I show you here. So the first is the capacity. Capacity is also means that how much the water is evaporate. So it's same as the value of mass flow rate of distillate. So as you all know that we call the value that we collect is the volume of distillate. So in order to find the mass, we have to convert it by times it with density at Tt2 and divided it by T. So it same goes to the rate of concentrate which we need in mass flow. We convert the volume to mass and divided it by the time. So rate as just now I said, rate of distillate is same as the capacity, and condensate also same, which we convert the volume of condensate to mass flow. And next one is the percentage of feed evaporate, which means how much the feed it evaporate into vapor. So of course we divide mass of distillate, which is mass of distillate by the mass of concentrate plus mass of distillate, because the total of mass of concentrate plus mass of distillate is the feed mass flow rate. As you all know that mass in equals to mass out, and we times it by 100%. And next is sensible heat load, is the measurement of how much heat energy required to increase the temperature. So the formula is the mass times the specific heat capacity and the temperature difference. The mass is the feed mass. Cp will be set at 4.18, and the Tt2 will be minus by Tf. Tf is room temperature, which we set as 25 degrees Celsius. And the next one is evaporated heat load, is how much the heat required to evaporate the water at this mass. Ms is the mass of condensate, steam condensate, and lambda is the latent heat at Tt1 at the steam temperature. And next is heat input into the evaporator will be the sum of sensible heat load and the evaporative heat load. And last but not least is the economy, which we divide mass of distillate with mass of condensate, because economy basically is how much steam that we require to evaporate the water. Okay, thank you. That's all from me.
Hello, my name is Ayu. So I will continue for my part, which is discussion. First, from this experiment, we can obtain 4 data, which is concentrated volume, distillate volume, condensate volume, and also the height when the boiling takes place. And also for the rate of evaporation and steam economy can also be obtained through calculation. We use two different time interval, which is 5 minutes and 10 minutes. And also we use a vacuum because it can reduce the boiling temperature for liquid to evaporate. The first study is on the effect of steam pressure on the rate of evaporation. We fix the feed flow rate at 41.86 milliliter per minute. From this result, we obtain these 4 value. The 3 of these obtained are increased, and for the height when the boiling takes place are 50, 46, and 37 cm. Based on the literature, when the steam pressure increase, the concentrate volume decrease, distillate volume increase, and condensate volume decrease. This is because when the steam pressure is higher, it will have higher temperature, and therefore more energy is transferred from the steam to the water, and only small amount of steam is needed. However, there is a slightly error on the result obtained, where it might due to overflow of the liquid to the concentrated solution tank, and also might came from the fluctuation of the steam pressure, and that will cause the inaccuracy of the result. And in this experiment, we need to record the height, and the higher the level of the height, the lower the value in the measurement. And this is because the reading we take is start from the top, and we know that the zero value is start from the above. And so this is the value we obtain. Therefore, the result show that the height is decreasing when the steam pressure increase. This is because boiling process take place faster, so only shorter distance is required to boil the water. And for the graph, when steam pressure increase, the rate of evaporation increase, and steam economy also will increase. This happens because as steam pressure increase, the specific heat will increase, where more heat will be transferred to the vaporized liquid. Therefore, the steam evaporator will have enough energy to climb up to the distillate, and that will causing the high value of evaporation rate. Moreover, as we operated this experiment under vacuum, it will have more supported energy for the steam to climb up to the distillate, and therefore the rate of evaporation will be higher. And for the economy, the steam economy increase because less steam is needed to vaporize the water. And from the table 2 in result, capacity is actually the rate of distillate, so it increase as steam pressure increase. And the data for sensible heat, evaporation heat load, and also heat input to the evaporator also increase as steam pressure increase due to higher energy transfer. For the second study is on the effect of feed flow rate on the evaporation rate. So this time we fixed the pressure at 0.3 bar. From the result, we obtain the concentrate volume, distillate volume, condensate volume, and the value are as follow. And for the height when the boiling takes place are 20, 27.5, and 31 cm respectively. Based on the literature we get, when feed flow rate increase, the concentrate volume increase, distillate volume decrease, and condensate volume increase. When the flow rate increase, at the same time it will decrease the exchange of energy between feed and steam, and therefore more steam is needed to vaporize the water. And for the height, it is shown that when the level of height decreasing, and as I mentioned before, the zero value is start from the above, so that's why the value in the measurement is higher. The value is higher when the flow rate increase. But suppose that the level of height have to be increased, because higher flow rate will increase the height of the liquid column in evaporator, and it will result in a large amount of washover when there was increase in vapor, and ultimately this dilute the liquid. And the result is different from the literature because it might be due to some error where the feed flow rate at condensate is stopped, and cause the evaporated steam cannot be condensed to liquid as it doesn't have any cold medium to transfer the energy. And for the graph in the result, when feed flow rate increase, the rate of evaporation increase, and steam economy will also increase. But then suppose that the rate of evaporation and steam economy decrease. A higher flow rate will decrease the exchange of thermal energy between feed solution and steam, and therefore the evaporated steam doesn't have enough energy to climb up to the distillate, and it will cause a lower evaporation rate. For steam economy, it has to be decreased as feed flow rate increase because more steam is needed to vaporize the water. From table 4 in the result, we know that capacity is actually the rate of distillate, and the results show in the table increasing trend, but it's supposed to be decreasing. The sensible heat, evaporation heat load, and heat input to the evaporator also increase, but based on the literature, it has to be decreased due to less energy transfer. However, for the overall data in table 2 and table 4, we can see that the last reading from the 3 trial have different trend, and this is because the time residence, which is 10 minutes longer, so that's the reason why the trend is different. So that's all for discussion.
Hi doctor, my name is Nurain Zuhaira binti Zulkifli and I'm going to explain my part, which is the conclusion for this experiment. First, the aim of our experiment is to study the effect of steam pressure and steam flow rate to the rate of evaporation of the liquid in the climbing film evaporator. When we manipulate the steam pressure, the rate of evaporation increases as the steam pressure increases. This is because when we increase the steam pressure, the temperature will increase. Thus, the energy used also increase. The distillate increase as the pressure increase, so the economy increase significantly. Um, the economy can be obtained when we calculate the mass of distillate over mass of condensate. Next, the height when the boiling occur in the evaporator decrease as the pressure increase. Then when we manipulate the steam flow rate, we can conclude that the rate of evaporation increased until it reached 62 kg per hour, then it decreased afterwards. The economy for when we manipulate the steam flow rate follow the same trend with the rate of evaporation. The height when the boiling occurs also decrease with increasing flow rate. For this experiment, it is recommended that we need to make sure the leftover content in the distillate and condensate is fully removed before we measure the next sample, the new sample. We also need to make sure that the pressure that we select, which is the 0.2 bar, 0.44 bar, and 0.66 bar, is maintained at the selectable pressure. And I think that's all from us. Thank you.